And we're on.
Okay. Hello everybody. This is going to be a short video doing an introduction to stoichiometry. We're going to look at the idea of the mole and how do we calculate grams per mole. So those are going to be our three things that we're going to look at. First off, what is stoichiometry? Well, it's this nice Greek word, but let's get down to the point here. Think about it this way. It is the mass of reactants or the mass of ingredients. Combine it to see how much of a mass of product are you going to get. So if you think about it, if you wanted to make one apple pie, you need an apple pie of a certain weight, certain mass of apple pie. You're going to need a certain mass of apples. You're going to need a certain mass of flour. You're going to need a certain mass of egg. You're going to need a certain mass of butter and a certain mass of cinnamon. Okay, so those would be your ingredients, your reactants, and then of course you go on from there. So that's the idea. Stoichiometry is that relationship between how much ingredients, how much reactants you have compared to how much product are you going to end up with. It is true you can have an excess of something where there's more than enough to do the job. But anyways, now one of the key things that you have to look at when you look at stoichiometry is something called the mole. Now, in biology, you do have the animal mole, the rodent-like creature that digs underground and, okay, that's not that kind of mole, although we use it as a symbol for it, but the mole is basically a number. It is not a condition, it is not temperature, it is a number. It is a very large number, which in this case is 6.02 times 10 to a 23rd of anything. So we can talk about a mole of hydrogen atoms. We can talk about 2 moles of hydrogen atoms. And I like to refer to that as the chemist's dozen. And the reason for that is because chemists use that all the time. Excuse me. We talk about the baker's dozen being 13, for example. When people think about the word dozen, they're thinking 12. If I say, get me 2 dozen pencils. If I say, get me 2 dozen boxes of copy paper. Oh, okay. And people will know it automatically. Well, in chemistry, when we talk about the mole, it is a number. It is a very large number. So when we talk about 1 mole of hydrogen atoms, it's going to equal 6.02 times 10 to the 23rd atoms of hydrogen. That's it. Okay? If I look at 1.5 moles of, let's say, helium atoms, okay, that's going to equal 9.03 times 10 to the 23rd helium atoms. Okay, so we can have more than 1 mole, we can have less than 1 mole, and typically in chemistry, we're working with less than 1 mole when we work with labs, okay? Not a big deal, but I want you to be comfortable that the mole is a number. That's the main idea for it. Now, let's move on, because that's only one part of the story. Now we have to talk about something called molar mass. Now, molar mass is a bit different. Okay, we want to find out how much 1 mole of something weighs. And I did have a lab where I would have students come in and measure out a mole of water, a mole of salt, a mole of iron, and they had one thing in common. They all were 1 mole, they all had the same number, but they had different masses. Well, why is that? That's because iron and water, okay, and salt, they're all different. Well, iron's an element, and water and salt, they're compounds. And they're different, they're made up of different things. So they're going to weigh differently. And that's the key thing here. So when we talk about molar mass, okay, it's the number of grams to 1 mole of something. Now, at that point, does Avogadro's number, does this number enter into it when we talk about grams per mole? No. Why not? That's because that's a number, that's not a mass. Okay? How many pounds does a dozen cartons filled with office paper weigh? How many pounds does 1 dozen Hot Wheels weigh? How many pounds does 1 pencils weigh? Okay? And you're going to know immediately, they all have the same number, the dozen, but they weigh differently because they're made up of something that's different. They're different items. So the only time you need to worry about this is if we're asking you for how many atoms there are, or how many molecules, because we can talk about 1 mole of molecules. That's the only time we have to worry about that. Okay? All right. Now we look at molar mass here, and we see it's okay, how many grams are there in a mole of something? You'd say, well, wait a minute, what are you talking about? Well, if I look at the molar mass, it's going to be grams per mole. So why don't we do that for 1 mole of hydrogen atoms equals how many grams? Well, where would you find that information? You would find that information on your periodic chart. Okay, we go back to the periodic chart and you look for hydrogen. Oh, there it is. And notice I only said H, not H2. There is definitely a difference. So for hydrogen, you look there, there's the atomic number. Okay, we know it's got its 1 proton. We got the element symbol, the element name, and then we have the average atomic masses, which is what we use, and we find it's 1.01. Now, we used that earlier in chemistry. We talk about atomic mass units. But for practical purposes, when we do stoichiometry, we look at this as 1.01 grams per mole. So when I go back here, how many grams does 1 mole of hydrogen atoms weigh? Well, I looked on the periodic table and it's 1.01 grams. That's how much 1 mole of hydrogen atoms weigh, which, wow, that's not much. It isn't. But then hydrogen's very tiny, isn't it? Now, how about 1 mole of uranium atoms? And we're going to take, okay, well, we can go back. And again, where would I find 1 mole of uranium atoms? Well, I can go back, I look on my periodic table, and I find right over here, over in the lanthanide-actinide series, 92. Okay, that's the number of protons I've got. There's uranium. And in this case here, it's a little bit fuzzy, but we're going to go ahead and say 238. We'll just go with that. All right? So that means then 1 mole of uranium atoms is equal to 238 grams per mole. That's the idea about this. Okay? Now, how can we figure out the grams per mole of a compound? Okay, well, let's look at how many grams in 1 mole of water. Everybody knows water. Okay, I like using water as an example. Well, there's a couple of things to look at. One, we have to look at how many of each do we have. Well, we have an H, we have another H, and we have an oxygen. Okay, so again, we can go back to the periodic chart, look for our H. There it is, 1.01. We can look for the oxygen and say, oh, look, there's 16. Okay, so I know H is 1.01 grams per mole. The other H is 1.01 grams per mole, okay? And then oxygen has 16 grams per mole. This is what we have. Now, all you need to do at that point is add them up, and you get 18.02 grams per mole of water. Yeah. It's not too bad, is it? All right, let's do another one. Okay. number of grams in 1 mole of, how about O3? This is ozone. This is what we find in the atmosphere. Helps block out the ultraviolet radiation. Well, here's the thing. What am I looking at? Well, I'm looking at 3 oxygens. So I know if I could break it down like this, each oxygen is 16 grams. How would I know this? What's my evidence? Right here on the periodic table. Oxygen's got 16 grams to 1 mole. So then we just add those up. So we have 48 grams per mole for 1 mole of ozone. And that's it. That's it for that. Not too bad. All right, well, what about for something like ammonia? Now that's something you can find in the household, so we'll go with NH3. Okay, well, we can again break it up into N and 3 H's. Now, do you have to do this every time? No, I'm just showing you where am I getting the numbers from. Because basically, this is a bit of addition. Okay, so wait. I know hydrogen is 1.01 because we had it in our previous example. So I know it's 1.01 grams per mole. That part I got. Well, what about the nitrogen? Well, whoops, wrong one. That's the one I need. So nitrogen, I look for it. Here it is. Element number 7, nitrogen, 14.01. Okay. So I looked up my periodic table. And then I just add them up for ammonia. So I've got 4, 0. So I have 17.04 grams per mole of ammonia. Okay? All right, let's see. Let's go with something, why don't we go with something a little bit bigger? Why don't we go for something like, the number of grams in 1 mole of C3H8. Okay? That's a nice juicy one. That's a nice hydrocarbon gas that we can burn. So, what do I know about it? Well, I can go ahead. I know I have hydrogens. There's 8 of them, so I can go 8, because that's how many hydrogens I have, times 1.01, and that'll equal 8.08. Now, I have to look up carbon, and I have 3 carbons in here. I have that right there, so you can see that. But now, how many grams are there in 1 mole of carbon? I look for it. There it is on the periodic table, 12.01. Notice it's not 6. That is the atomic number. That tells us how many protons there are in the nucleus. It doesn't tell us how much it weighs. This is telling us how much it weighs, 12.01. So we're going to go with that, 12.01. And that's going to equal to 36.03. And then we just add it up. So we have 1 mole of C3H8 is equal to 44.11 grams per mole. That's basically it. Okay, so let's wrap this up. We talked about what was stoichiometry. It's a relationship between the mass of your reactants or ingredients and what's going to be the mass of products that you're going to get out of it. A key thing that we use in stoichiometry is something called the mole. Now the mole is a number, a giant number, also known as Avogadro's number, okay? And that's 6.02 times 10 to the 23rd. Very massive number, just for calculating the number of items in that mole, okay? Then we looked at, well, how many grams does 1 mole of a chemical compound weigh? How in the world did we do those examples? Okay, we talked about the molar mass. Okay, we did the number of grams in a mole of water, the number of grams in a mole of ozone, and then we did 2 more here, okay, for ammonia, and that lovely hydrocarbon there whose name escapes me at this very second. Okay, I hope this helps you out. Okay, there are other stoichiometry videos that will be coming out where we're going to do moles to grams, grams to moles. Okay, and then doing the big equation stuff. All right, take care.